So the problem you're asking me about says that in 2003, so that's a year, we have college A that has 15,900 students. And then it says we add 800 students per year. So each year there's 800 more students. Sorry, my writing's not very good on this tablet. So then we have college B, and it's starting out with 27,900 students, but it's saying the enrollment is declining. So we're going to subtract 700 students per year. So can you see that college A would be going 15,900 plus 8 to 16,700. Then the next year they would have 17,500. Then the next year they'd have 18,300. And so on. So you see their numbers are getting bigger by 800 each year. Then college B is we're taking away 700 each year, so I get 27,200. Then subtract 700, and I get 26,500. Then I subtract 700, I get 25,800. So do you see that the numbers are getting closer together? So I start with 15,000, 16,000, 17,000, 18,000. Then this one I started with 27,000, 27,002, 26,000, 25,000, 24,000. So you see how they're getting closer together. So what we're looking for is when will they be the same? So this is the section about linear models of how can I write an equation that says what's going on here. So if I let x be the number of years that have gone by, then does it make sense that college A will have 15,900 plus 800 times x? So the first year we add one group of 800. The next year we add two groups of 800 because 2 years have gone by. The next year we're adding three groups of 800 from what we started from. So this equation is an equation that tells you how many students are there after X years. So can you see that for college B, we would start with 27,900, but now we're subtracting 700 students each year. So in general, when you see the word per or each, you're going to multiply by something to get a total. So it's 700 each year, but if you want to know the total number of students left, you're going to have to multiply that 700 by, I took 1 year's worth of students off, 2 years, 3 years, and so on. So the question's asking you, when will their enrollments be the same? So you're asking the question, when will the number of students at college A, 15,900 plus 800x, be the same as the enrollment in college B, which is 27,900 minus 700x. So then do you see that this is solving a linear equation? So I would add 700x to both sides and have 15,900 plus 1,500x equals 27,900. Then if I subtract 15,900 from both sides, and they made these numbers work out really nicely, I have 1,500x equals 12,000. So to solve for x, I'm going to divide both sides by 1,500. So x is going to be, let's see, I divide both sides by top and bottom by 10, but divide top and bottom by 100. So I have now 120 over 15, which I can reduce because 5 goes in here 24 times and 5 goes in here 3 times. So I see that the number is 8. Well, up here I wrote what x equaled to, so that makes it easier for me to interpret my answer. So 8 years after we started at 2003 is when the enrollments will be the same. So that year would be 2011, right? So in the year 2011, the colleges will have the same enrollment And it doesn't matter which equation you use because their enrollments are going to be the same at this time. So I can do the 15,900 plus 800 times 8 to see what that college's number will be. So that's 15,900 plus 6,400. And I'm not very good at horizontal adding, so I'm going to put it underneath here. So I get 22,300, but notice that if you use the formula for college B, let's make sure we get the same thing. So I'll have 27,900 minus 5,600. So let me subtract vertically because I do a lot better job that way. And I get the same number. So this is students, because when we wrote these equations for A and B, they were number of students. So this was students. So when I put an X value in there, the number that I get is students. So let me know if you still have questions after watching the video.